What's up guys, Onmaths here, and today we're looking at sequences. So first up, AQA, and we're starting with quite a simple one. It tells us what the first term is, which is -1, and it asks us to work out the third term. So the first term is -1, and the term-to-term rule is multiply by 8, then add 11. So what we're going to do is we're going to times it by 8, which would be -8, because a negative and a positive make a negative, and 1 times 8 is 8. Then add 11, so we're going to add 11, which would give us, so -8, and if you don't know, just do yourself a quick number line. And so we're at -8, which would be here, and we're adding 11. And the answer should be 3. And then that's the second term, so we've got to do that again. So we're times that by 8, and so that would be 24. Then we're going to add 11, so that would be 35. So the answer to that would be 35. Okay, let's move on. So the order of the first 3 terms is reversed to make a new sequence. So the new sequence would be 35, 3, and -1. And it says work out the term-to-term rule. So we had the term-to-term rule for one way, and we're basically doing the inverse. So I'm going to do a mirror image, but I'm going to do the inverse of each of them. So here is equivalent to this bit here. And so what we did there was we added 11. So the opposite of add 11 would be minus, if I do it in the right colour, so it would be -11. And so 35 take away 11 would be 24. And then this bit here is equivalent to this bit, because we're working backwards. So what's the opposite of times 8? Well, it would be divided by 8. So 24 divided by 8 is 3. So the answer to this will be, and let's see how it did it. So it wrote them out in words, so I'm going to write that out in words. So subtract 11 and then divide by 8. Now commonly students, when they do the inverse, they would do it in the order which it said it in the question. If I just highlight it, they would say divide by 8 and then add 11. But you don't do it from that way, you do it from this way. So subtract 11, divide by 8, and hopefully this shows you why. Next up is Edexcel's question, and with this question we've got a kind of visual sequence, and we've got square tiles and we've got circular tiles. And it's asking us how many square tiles are needed to make pattern number 6. Now, sometimes it's sensible to draw out pattern 4, 5, and 6, and then see. With this one, it's going to get really complicated, and it doesn't look like it wants us to do that because there's not an awful lot of space here. So let's just have a look at how many square tiles there are in each one. So this one starts off with 1, and then this one is 4, and then this one is 9. Now what do you notice about 1, 4, 9? You should notice that it's the square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So the next one will be 16, then 25, and then 36. Now if you don't know your square numbers off by heart, and you should know them up to 15 squared, up to 225, you have to know them. You have to just sit and learn them. Maybe on a Saturday or Sunday over breakfast, just sit with the list and just learn them, because you will need to know them, and this is an example of why. Next it says how many circular tiles are needed for pattern number 20. So it seems like there's a definite pattern here with these circular tiles. So how many circular tiles are there? And I'm going to draw this underneath. So there's 4 for the first one, and then there's 2, 4, 6, 8 for this one, and then 3, 6, 9, 12. So how do I get from 1 to 4? Well, I could add 3. Let's see whether that works for the next one. So 2 plus 3 is 5, so that doesn't work. What about if I times it by 4? 1 times 4 is 4, that works. 2 times 4 is 8, that works. 3 times 4 is 12, perfect. So I need to times it by 4. So I get the pattern number, which is 20, and just times it by 4, which will be 80. Let's have a look at the last one. So Derek says, when the pattern number is odd, an odd number of square tiles is needed to make the pattern is Derek right? And you must give reasons for your answer. So let's just see with the ones we've done whether Derek is correct. So the first odd number in our sequence is the first one, which is 1. And there was 1 square. Okay. The next odd number was 3. And there was an odd amount of squares there. Okay. So it seems that he's right with the ones we've got. And let's think logically here. So we've got pattern number. And how are we getting the squares? Well, what we do is we square it, and that gives us the amount of squares. Okay, so if the pattern number is odd, and we square it, now squaring just means times it by itself, so times by itself, we know an odd times an odd is always going to give you an odd number. Okay, 1 times 1, 3 times 3, 5 times 5, 25. Every time you do an odd times an odd, it always gives you an odd number. So all you need to do here is write down, I think probably that's going to be enough there to write down and get both marks. But you need to have a conclusion as well. So it says, is Derek right? So yes, because when you square an odd number, you will always get an odd number. It's probably way too much, but make sure that you write down an actual conclusion. This part here is very, very important for these types of questions, as well as all of the explanation as well. And last up we've got OCR, and OCR starts quite easy with question A, but question B is really what I'm after with this question. So let's rattle through question 10A, and it says to get to the next term, subtract 4. So we're just going to take away 4 from 19, which hopefully will give us 15. Take away 4 from 15 will give us 11. Multiply the previous term by 5, then add 3. So we're going to times by 5 and add 3. So 7 times 5 is 35. 35 plus 3 is 38. And we're going to times 5, then add 3. So 38 times 5. Well, we have a calculator for this one, so type it into the calculator, and we then need to add 3. Be 193. So 38 times 5, 190, plus 3, 193. Right, this last bit is the bit I'm interested in. So this is asking us to find the nth term for the sequence. Now there's a really, really simple method to work this out. Every teacher teaches this slightly different, but this is definitely the way I found it easiest to explain. So you've got to first of all work out what the sequence is going up in, and that's really important. So 5 to 9 would be plus 4, plus 4. Always check that the pattern continues. Now whatever it's going up in, that number there goes before the n. So this sequence is 4n. But 4n, just on its own as a sequence, is the 4 times table. And the 4 times table would go 4, 8, 12, 16. Okay, so you can see that's not the right sequence. So we've got to do something else. Now to work out what that other thing we need to do is you go back one. Okay, so if I went to the 0th term, so back one, I'd obviously take away 4 because we're going back. And what number would that give me? Well, 5 take away 4 is 1. Now that's a positive 1, so it means it's going to be a plus 1. If you went backwards and it gave you a negative, obviously that would be take away. And so the answer to this question is 4n plus 1. Now this is the simplest method that I think I've ever seen and ever worked with, and students I've taught this to have been really, really happy with it. So if you're not quite sure about the method you're using, definitely move across to this one. If you're happy with the method you're using and it suits you well, then obviously feel free to keep using it. Be careful because sometimes there's square sequences, sometimes there's Fibonacci sequences, so it's not always going to work. If that plus 4 there if those +4s weren't all +4, +4, +4, but sometimes they might be +4, +5, +6 or something like that, then you've got a different type of sequence. This only really works with linear sequences, which means they go up by the same amount each time. Well, I hope that video has been useful. If it is, please click like. Also, feel free to write any comments about future videos or about this video. If you like this video, also we release videos every single weekday, Monday to Friday at 9 o'clock in the morning. Click subscribe and click that bell to make sure you're up to date and you get all of the latest videos delivered to you. If you want to see more from us, we have a website, onmaths.com, which is crammed full of free resources, completely free, and you can even sign up to save your scores, also free. Just go across there. There'll be a magic card appear above me now. Just click on that, it'll take you to our site. You can have a look around and see if there's anything there that interests you, which hopefully there will be. Otherwise, thank you very much. I'll see you tomorrow.